Assalamualaikum and hi everyone. I begin by introducing Work Unit 1, Mineral Preparation Technologies. This unit involves preparing rock and soil samples for lab testing by using machines like jaw crusher and pulverizer. While these machines make the process faster, they also involve safety risks such as chemical exposure and dust inhalation. So it's important for workers to follow proper safety procedure.
The process at work in Unit 1. Staff members get a sample from a client. After that, two technologists prepare a depleted nitric acid solution by diluting concentrated HNO3 65% to a 5% HNO3 solution. Same technology crushing and pulverizing the sample into fine powder. After that, technology cleaning the jaw crusher and pulverized machine trays by soaking them in the pre 5% HN3 solution. The tray will then be rinsed with the distilled water, followed by ethanol. Lastly, all apparatus used in the process will be cleaned with a distilled water, rinsed with alkaline, and placed in an oven for drying. So this is a list of chemical hazards to health and their properties, such as health hazard classification, classification code, source, SDS or ICOP. So the chemical of hazard to health that used in this uh, work unit 1 is lactic acid 65%, nitric acid 5%, ethanol, and acetone.
Hello and welcome everyone. In this video, I will be discussing the hazard rating for exposure to inhalation based on the CHRA manual, specifically Table 1 on page 27. The first slide that I want to discuss is identifying the hazard rating for inhalation exposure. Inhalation is one of the main routes of exposure to hazardous chemicals in the workplace. When workers breathe in vapors, gas, dust, or mist, this substance can enter the lungs and bloodstream, causing harmful health effects. According to Table 1 in the CHR manual, the hazard rating, or HR, is based on how toxic a substance is when inhaled. This is usually measured by its LC15 value, which refers to the lethal concentration that kills 50% of test animals. The hazard ratings are as follows: HR4 very high, LC15 less than 500 ppm for gases, or 2 mg per liter for dust or mist. These chemicals are extremely toxic. The second one is HR3 high, LC50 between 500 to 2500 ppm. These are also dangerous and require strict control measures. And the third one is HR2. Uh, Danger level is moderate. LC15 between 2015 and 5000 ppm. Still harmful over long exposure periods. And the fourth is HR1 low, LC15 more than 500 ppm. Minimal risk if handled properly. And the last one is HR0, a very low, non-significant hazard by inhalation or no data available.
Assalamualaikum and hi everyone. My name is Muhammad Fahmi bin Amtungho and I be presenting about hazard properties for dermal exposure. Dermal exposure happen when hazardous chemical come into contact with the skin. This can occur through direct handling, accidental splashes, and or touching contaminated surface and equipment. In the gold analysis lab, there are several common routes of exposure. The first one is handling acid and reagent without proper gloves. The second is cleaning chemical spills or using equipment that has chemical residue. Here are some of the chemicals we identify along with the hazard types and effect on the skin. The first one is hydrochloric acid and nitric acid are corrosive and can cause a burn. The third is aqua regia. It's even more corrosive and can result in deep tissue damage. The fourth is sodium cyanate and arsenic compound are toxic and can be absorbed through the skin, causing serious internal effects. While acetone, which is often used for cleaning, is an irritant that can dry and crack the skin if overexposed. The last one is health effect and protection against dermal exposure. If not controlled properly, dermal exposure can lead to both short-term and long-term health effects. Short-term effects include redness, pain, and chemical burns. For the long-term effect may lead to chronic dermatitis, skin sensitivity, or even systemic poisoning in the case of toxic chemicals like arsenic and cyanide. That's why it's crucial to apply effective control measures such as standard such as wearing chemical-resistant gloves, lab coats, and face shield. Following standard operating procedure (SOP) when handling chemical and checking the condition of personal protective equipment (PPE) regularly, and using emergency shower or wash station immediately if any contact occurs. In summary, proper understanding and handling of chemical hazard for dermal exposure are essential to protect laboratory workers from skin-related injury and health risks. Thank you.
Hi, I'm going to explain the purpose of the calculation, which is to determine the time weight average or TWA8 for acetone exposure during an 8-hour work shift. This helps us understand how much acetone a worker is exposed to an average and whether it is within the safe limit set by regulations. Based on the chemical exposure data, one technologist was exposed to acetone during two different activities through an 8-hour shift, which is sample 1 240 minutes on 4 hour at 500 ppm, and sample 2 to also same 240 minutes of 4 hour at 18 ppm. The formula for TWA is C1 times T1 plus C2 times T2 divide 8 to get the calculation. For C is the concentration in ppm, T is the time in hours, total time is 8 hours. As you can see, there's the result that we have calculate, and that's the answer for the TWA8 calculation. So the next part is discuss the level of exposure rating. Exposure to acetone vapor has been classified as moderate with a health risk, especially when repeated or prolonged exposure happen. Skin rash cases that were observed could be linked to direct chemical contact or improper donning and doffing of personal protective equipment (PPE), while lab coat, gloves, gloves and surgical masks are present, it is noteworthy that surgical masks should be not used for filtering chemical vapor. Even an 195 mask give limited protection. The recommended treatment is to use a respirator with organic vapor cartridge. From the perspective of engineering controls, a fume hood is present, and that is positive step. However, there is no suggestion to know whether it's performed properly in removing poison vapors. Organization level itself lacks training records, which suggests that employer may not be complete aware of proper chemical handling practice, leading to unsafe behavior. For emergency preparedness, it is urgent to have spill kits, fire extinguishing, and eye wash station, but this must be impact on a regular basis and well-trained staff for prepare used to be prepared for effective emergency response. That's it for me. Thank you.
So, for safety improvement for grade work unit 1, PPE and emergency preparedness review, lack worker with incomplete PPE. Current problems, what's wrong right now? So, three key issue. First of all, PPE fails. Mask don't filter fumes and no eye protection. Second, missing emergency shower. And for the third, no training or maintenance record. So, to solve the problem, there is three solutions. First of all, we need to buy a better PPE. So, for example, chemical respirator and goggle. For second, install emergency shower and test spill kits. For the third, we need to train the staff by using USECHS compliance and drills. So after we solve the problems, there will be a benefit there. First of all, we can prevent injuries and lawsuits. Second, complies with USECHS Regulation 2000 and boost worker morale. Last but not least, let us work together for a safer place.
In conclusion, this unit plays a key role in sample preparation. However, it involves risks like chemical hazard and lack of proper safety record. Although PPE and fume hoods are used, these are still gaps such as unverified emergency tools. We recommend improving safety procedure and providing proper training for all staff.